So this talk's going to be a little bit of light relief. We've had a lot of Angular today, and there's almost no Angular in this talk at all. That would have been a really bad start. My laptop nearly just fell off the podium. It's also not going to be quite as attractive as the Angular material talk either, but hopefully it'll be something that's interesting and useful to you. So who am I? I'm Pete Bacon Darwin. I'm the London annex of the AngularJS team. I've been working with them for about a year or so now. My surname is Bacon Darwin. Bacon's not my middle name. It's often confusing to many people, so I just thought I'd point that out. Today I'm going to talk about Dgeni. These are the highlights of the talk, so if these don't look interesting to you, you can go and get a drink instead. By the end of today, I'm hoping that you're going to be a little bit inspired to go and have a little look at Dgeni and maybe try it out, and maybe it'll be useful to you in your own projects. I'm going to start with a little quiz. When I put this this talk together, I didn't expect there to be quite so many people in the room. So I'm not going to actually ask you to answer these questions, because that might take too long. OK, so what's the syntax of the method on the $SCE service in AngularJS that you use to declare a string of HTML? So have a quick think. Trusted HTML. OK, so $SCE.trust as HTML value, and the value is the HTML you want to trust. And if, with any luck, we'll have a link to the website which contains that information. This is the slow bit, so we'll keep going. Next question. So AngularJS is easy, yeah? We all know AngularJS really well, so that's an easy question. Probably there's a few people using Protractor here, so you might be able to answer this one. How would I access the second row of this repeater? It's a repeater which has got, it repeats over a bunch of cats in pets. So we use element by repeater, cat in pets, row number 1, because it's 0-based. I could click on the link and show you the documentation for that as well, but I suspect it might take too long. And we've been talking a lot about mobile today already, so here's one for the INOC framework. What's the directive you'd use if you wanted to have a pull-down refresher, you know, like you have on Twitter? When you swipe down, it refreshes. And this is ion refresher, and you can go and see the documentation for that too. So the question is, how do we know this information? In the old days, you might have a nice big fat reference book, like the Window API book by Petzold. I had a copy of this like 10, 15 years ago, and you would look through it to find the particular API item you wanted. More recently, in the open source community, you might go to the source, because source code is available in all open source projects, and it's a pretty good place to find information about what the syntax is for a method call, and maybe even what the code is going to do for you. But probably most of you are going to hit some kind of documentation website. And projects, especially open source projects, go to great efforts to document their, if they're good projects, they go to great efforts to document what they do, and some of them do a better job than others. So I think we can all agree that we like the docs. In case you're not aware of Doctor Who, this is one of the more recent doctors. The key thing about docs, though, is that they have to maintain a level of freshness. Yeah? There's nothing worse than stale docs. Yeah, it's a bit like bread. I think if you've got to choose between stale bread and no bread at all, you're probably going to want to go with no bread at all. So how do we actually stop the docs from becoming stale? The most important feature is to put it into your process. So whenever you're changing the code, you need to change the docs as well. And you can do this through many methods. You can have a manager that stands over you and checks that you're doing it properly. But even in that case, then it might get missed. So what do we do in AngularJS? What we do is we put the docs as close to the code as possible. And we also store it inside the same repository. So whenever we're looking at a review of a code change, we can immediately see whether they've updated the docs accordingly, and send a message back to the person who's changed it to ask them to can change to the docs. But how do we do this in AngularJS? That's the ideal idea, but how do you actually achieve this? So what we did was we took a trick from JSDoc and many of these comment-based documentation systems, where you tag you tag your documentation inside a comment that's actually right next to your code. And then you need something that will extract that information and convert it to a website. So the AngularJS team looked at JSDoc, and it's amazingly powerful. It parses your code, and it tries to make the best guess of what your code does, which is pretty impressive given how dynamic JavaScript is. But in AngularJS, there's a bunch of concepts which are quite specific to how we work. And so things like controllers and directives, it's quite hard to get that information into a good state just using JSDoc. And so in true developer fashion, we built our own tool. And this tool was originally called ngdoc, and it lived inside the AngularJS project. But as the project grew and the documentation got more complex, this ngdoc tool got more and more complicated. And by the end, it was about 1,800 lines of code. 1,200 of those were in a single file. And it was really hard to find what was going on in there. And around about the end of last year, I was trying to remove colons from file names in the documentation, because, of course, everyone knows that in Windows you can't have colons in file names. So this would enable us to build the Angular docs on Windows environments if you ever wanted to do that. Doesn't happen much inside Google. And I tried in vain to do this, but it was so difficult. The colons were dotted all over the code. And so I decided it was time to refactor. So thus came Dgeni. So I just took a step back and started from scratch. And the idea was to try and code up a tool which followed good design principles. So everything was going to be a cohesive little component which were decoupled from the other components. I wanted to take lots of the ideas that we get from AngularJS, which make it such a joy to work with. So using dependency injection. And of course, testability is key. So I wanted to make sure that the whole code base was really strongly tested. And at the moment, the tool itself has got 100% code coverage in terms of tests. And most of the packages that we use also have that. So Dgeni was designed from the beginning to be fairly flexible and configurable. And although it's quite an immature project in many ways, it's got some pretty important projects that are using it. You'll notice in the last presentation that Max kept saying, and we generate all these documents from the code, and it's really cool. Hey, what you didn't mention the fact that it's generated using Dgeni, yeah? But I'm sure that the point of that was so it wouldn't sort of take the wind from under my sails. So he gave me the opportunity to say that. But you can see there's a couple of others here. But what's really interesting and fascinating about these 4 projects, also Famous, Angular Famous, the connection between Angular and Famous uses Dgeni as well, but I forgot to add that one in. What's really interesting, I think, is that each of these takes a very different approach to their documentation generation. They all produce documents in slightly different ways and then present them to the user in slightly different ways. But they don't use a huge amount of code on top of Dgeni to achieve this. So let's just quickly look at each of them in turn. AngularJS was the main project that we designed Dgeni for. What it does is it produces a partial HTML file for every single document in your code base. And then it presents those using an Angular app. It also has some really cool features like, which is also in the Angular Material project and in Ionic, I think, where you can have runnable examples of your code. So you actually pull out code samples from these comments and make them runnable inside your documentation. Protractor takes a slightly different view. What it does is it creates a big JSON document or object based on all of the documents that are in its source code, which it then provides to the user through a controller. What's also interesting about Protractor is that, yeah, they've got their own code, which they want to document, but they actually sit on top of WebDriver, which is also documented using JS.doc tags. And so they've managed to achieve a kind of a hybrid documentation system which brings both of these sources together and produces pretty useful, usable documentation. Angular material, as we saw already, you've seen plenty of examples of that in action in the last talk. And they have got, again, it's not that dissimilar to AngularJS, but they're using much more a set of iframes where each component kind of lives inside a mini app of its own, which is generated by Dgeni. And finally, the Ionic framework have gone completely, as you'd expect, they've gone completely in a different tack altogether. Their documents get generated into Markdown, which they then upload to GitHub to be served up by a Jekyll server, which is the standard serving mechanism of GitHub pages. So you can see that each of these is they've got a similar goal, but they're going about things in different ways. And I didn't talk about it, but you'll see that I was putting these lines of code markers on each page, which gives you an indication of the amount of effort that you need to configure Dgeni to achieve what they want to do. So let's have a little look at what Dgeni does. There's only really three key concepts. So although many people come to me saying, oh, it's got such a hard learning curve, and you ironically haven't really well documented the tool, once you get past all of that, you'll find it's actually really, really not too much mental effort to use Dgeni. These three concepts are all you really need to understand. So a processor is just a small unit of code which takes some docs and does stuff to them and then returns the new docs. So maybe it might add some more documents into the collection, or it might manipulate them in some way, or filter them. And what you do with Dgeni is you just create a pipeline of these processes, and Dgeni then just, when you run it, it just iterates through each of these processes in turn, and at the end of it, you end up having your processed documents. Okay, this is a kind of an idealistic pipeline, but it's not actually that far from what is really going to happen in your setup. Each of these processes and services, so services are very similar to what you'd expect in AngularJS. So if you're using AngularJS, the concepts will map nicely over to Dgeni. All of the things like, so processors, services, and also config blocks, which are similar to the config blocks you'd get on a module in Angular, can be injected via a dependency injection, which Voiter kindly wrote for us, which is used in Karma as well. And all you have to do is provide a factory function for each of your components, and it can then depend upon other services which can be injected in. So maybe this is a little bit small to see, but hopefully it's OK. In AngularJS, we put everything into a module and register our components on that module. So to try not to confuse things, I've changed the name to package inside Dgeni, but maybe that will cause more problems with ES6 coming. So you create a package. The package can actually depend upon other packages, which means that your components will be able to use the services and processes that are in the packages it depends upon. And then you just call factory processor config to register those components on that package. What you'll see is that this, if I didn't mention earlier, Dgeni is a node application. So we're using require here to pull in the actual code. This means that in our source code project, we can nicely break down our code into small, manageable chunks. So let's have a look at how we'd actually define a service. So we call factory and pass in either the actual service or require it in. And this is what it would look like. So because it's a node application, we're exporting the factory function. Dgeni's clever enough to realize that the name of the factory function is the name of the service. And in this case, we're just returning a function that will log the message that we pass in. Processors are basically just specialized services. They, again, have a factory function. And in this case, I'm actually depending upon the log service. So the dependency injector will bring that in for us as we need it. And the only thing you really need to do with a processor is provide the $process method. And this is what will actually do the processing inside the pipeline. In this case, what we're doing is we're filtering out all of the documents that don't have the ngdoc tag. And this is something that actually occurs. That code's almost exactly what's used inside the setup for the AngularJS project. We've got other optional properties as well, and you can see here run after and run before. This allows us to position our processor within the pipeline. So Dgeni uses those to work out where the processor goes. So if I depend upon a load of other people's packages, I don't have to know about the entire pipeline, but as long as I know where my processor needs to fit, I can insert it at the right place in the pipeline. And then finally, to run Dgeni, you just you require it in, you make an instance of it, and you pass in the package that you have carefully created. And finally, you just run generate on the instance of Dgeni, and this will trigger the pipeline. The processors will do their job. And what I didn't mention earlier is that processors, as well as being able to take a docs collection and return a docs collection, they can actually run asynchronously and return a promise to docs collection. And in that case, Dgeni's clever enough to set up the processing pipeline as a series of asynchronous tasks. So here you can see that we can actually deal with what happens when the generation has finally finished. Dgeni on its own doesn't do anything. It doesn't provide any processors. It's just an empty tool. So you've got to do some work yourselves, and you have to provide these packages and processors that do the job. But the nice thing about that is that you're completely free to do any kind of processing you want. You're not constrained to only reading in files. You could get the files from you could get the documentation from like stored procedures in an SQL server, or pull them from a content management system, for instance. And you can then manipulate them in any way you like. But there's a lot of common tasks that you do need to do in most generation situations. So I've created a few packages that you can rely upon and use. And these were primarily developed for the AngularJS project, but there's enough genericism in there that you can actually reuse them. I'm not going to go into the detail. If anyone's interested in really finding out what these things do, you can look at the code. You can come and talk to me afterwards. But what I wanted to just finish with is the last point, which was in my overview, was what's in it for you? Yeah, why should you really care about this? If you had to start from scratch, writing all your processes is going to require you to do a fair amount of work. Using those basic packages that are available, that gets you some distance. But what I've been working on over the summer is a sort of proof of concept, which hopefully will maybe be interesting to you guys. What this is a package which provides processors that will actually go and look at your application, parse the code, work out what modules you've got, what controllers you've got, and so on, and generate documentation without you really having to do too much configuration at all. And what I'm hoping to do is demo this in action. So this is the package I've written. You can see I've provided a bunch of services, and there's actually only two new processors. One's called parse modules, and the other one's called generate module docs. The parse modules has got a lot of funky code in it, which uses a Spremer to create an AST of your code, which it then searches to try and guess what is going on in your code. What this means, though, is that you have to do fairly minimal amount of documenting on your code. If we look at a sample piece of source, you can see here I'm declaring a module called mod2 and a controller called myControl. And all I've done in terms of documentation is provide a description. I haven't had to put at name or at module or whatever. Dgeni, the AngularJS package, which I've defined, is going to guess all of that for us. So in order to use this, this is the setup inside my example. I'm creating a new package called Dgeni example. I'm requiring the AngularJS package, which is my new package I've just written recently. But this actually also requires the JSDoc and the Nunjux packages. Nunjux, by the way, is a rendering engine that uses similar kind of mustache-style bindings to render any kind of text you like, but mostly you tend to use it for HTML. And then there's a little bit of configuration. And in these config blocks, I'm going to specify things like where the source code is and where to write it to. So that's kind of all you really need to do to use this package. And when it runs, and so Nunjux uses templates. So here's an example template of what a controller page is going to look like. I don't have the beautiful aesthetic abilities of some of these guys like Matthias, so you'll see that my HTML looks pretty raw. But I've sneaked in some Angular material tags in some places, so you might recognize some of the styling. Each template receives a doc object, and you can then do whatever you like with the properties on it. And so your processors will have attached properties to these docs, which you can then get hold of inside the template. And you'll end up with something that looks a bit like this. This is a controller that's been generated. You can see I've pulled in all the Angular material stuff there. And then further down, you can see that it's actually describing module 2. And it has some dependencies on module 1. And it's describing the controllers and directives that are there. So we can possibly, if I can work out how to do it. So this is what the really beautifully sculpted output is. You have to use your imagination a little bit. And one of my challenges to you is that all of this is driven by templates and CSS, yeah? So you can go away, clone my repository, provide a beautiful new set of templates and styles, and send them to me for a pull request to me, and I will, any of the really good ones I'm going to merge in and you can then have plaudits for being the person who designed the new style for this. We can have more than one, because of course it's all configurable. What's really nice about this is that I'm running Dgeni using Gulp. You can see here, this is the Gulp watch process in action. And every time I make a change to the file, it's going to rerun Dgeni. If I go and change some of the source, like I can go and change this saying even more cool get item, or even more cool helpers, yeah? Not quite as fast at typing as Andy. As soon as I hit save, then you can see that Dgeni has just run. You can see here that it's actually outputting all of the processes that the pipeline are running through. And if I go to the page and refresh, then you can see immediately the documentation's been updated. It's just a toy example. You may or may not want to do this, but you can see how Dgeni could fit nicely into your build process. Really, that's all there is to say today. If you want to come and find out some more information about Dgeni, and in particular this package, there's a lot to do on here. This is definitely a proof of concept. I'd really welcome people's input and help in making this something that is a turnkey solution for you to just point at your applications and generate documentation really easily. If I go back to here. Good old Wi-Fi. Is it gonna refresh? Come on. I know. I am online, but the Wi-Fi's struggling. Okay, so what we'll do. If I just zip down in offline mode, you can see it in place. So you can go away and code, you can add new processors, you can add your own templates. Many of the applications that use Dgeni provide a container application, which is maybe an Angular app, which then uses the output from Dgeni. So go away, create a nice set of templates, send them to me, and I'll be your friend forever. Here are some links in order to access all of this. There's Angular Dgeni is the main tool. Angular Dgeni packages is the place where those main packages are, but my examples are in my own repository, which is Pete Bacon Darwin organization. And finally, the main thing I want to say is thank you, because There have been a handful of contributors. Many of them are sitting along the front row here. I particularly wanted to say thank you to Stefan, who's not actually here, but he's been fantastic in supporting me. But also, every time I make a change to any documentation-related item inside Dgeni, he hits me with a translation into French within like 15 minutes, I think is the slowest he's managed to do it. So given that we're in Paris today, you'll be delighted to know that all of the READMEs inside the Dgeni project are also available in French as well. If anyone wants to translate them into other languages, then I'd be happy to hear from you. So thank you very much for listening to me today, and come and find me if you want to come and talk about Dgeni.